Welcome back to Nexus IT Insights. Kubernetes has become the backbone of modern cloud infrastructure. However, when we look at its architecture diagram, it can get quite confusing to understand how all these different boxes and arrows connect with each other. In today's video, we are going to break down this entire diagram step by step. We will explore what components sit inside the master node and the worker node, and trace exactly how a user request reaches the application. Every component will be highlighted and hovered over on screen as we discuss it so you can follow along easily. Let's dive right in. Let's start with the high-level layout. A Kubernetes cluster is essentially divided into two main parts. On the left side, the large box you see is the master node, also known as the control plane. This is the brain of the cluster, responsible for all decision-making, scheduling, and overall state management. On the right side, you see multiple boxes labeled node. These are the worker nodes. This is where your actual applications and workloads run in containerized form. Simply put, the master node gives the instructions, and the worker nodes execute them. At the top of the diagram, notice kubectl. Whenever we run commands using the CLI, whether to deploy containers or inspect cluster health, we use the kubectl tool. Kubectl sends those requests directly to the API server, which sits right at the center of the master node. The API server is the central gateway of the Kubernetes control plane. No other component, whether it's the scheduler or etcd, talks to each other directly. Everything must go through the API server. Whenever a request arrives, the API server authenticates and authorizes it first. To the left of the API server, you'll see a cylinder-shaped icon labeled etcd. etcd is Kubernetes Distributed Key Value Store. You can think of it as the main database of the cluster. All cluster data, such as which nodes are active, what pods are running, assigned IP addresses, and your desired cluster configuration, is stored securely and consistently inside etcd. It is considered the single source of truth for Kubernetes. As long as etcd data is safe, your cluster is safe. Now let's examine the remaining two core components in the master node. On the top left is the scheduler. Whenever you request a new pod to be created, the scheduler decides which worker node should host it. It evaluates CPU, RAM, and resource availability across all nodes to select the best fit. On the bottom left is the controller manager. Its job is to continuously ensure that the desired state of the cluster matches the actual state. For instance, if you tell the controller that you need 3 replicas of your web app running, it runs a continuous loop checking for those 3 replicas. If a pod crashes, the controller manager instantly instructs the API server to spin up a new replacement pod. Now let's shift our focus to the worker node. At the top of the worker node, you'll see Kubelet. Kubelet is an agent that runs on every single worker node and stays in constant communication with the master node's API server. When the master node schedules a pod onto a node, the API server sends instructions to Kubelet. Kubelet then commands the local container runtime, like Docker or Containerd, to launch the container and reports its health status back to the control plane. Directly below Kubelet are those orange boxes representing pods. In Kubernetes, a pod is the smallest deployable unit, holding your actual application containers. At the bottom of the node, we have two crucial networking elements. First is the service proxy, commonly known as kube-proxy. It maintains network rules and IP tables on each node, handling load balancing and routing incoming traffic to the correct pods. At the very bottom of the diagram, the long blue bar represents the CNI network, Container Network Interface. The CNI network, using plugins like Calico or WeaveNet, acts as an overlay network, assigning unique IP addresses to all nodes and pods so they can securely communicate with each other across the entire cluster. Let's trace what happens when an actual user accesses your application. On the far right, you see the user icon. When a user sends a request to your web application or API, that request hits the worker node's service proxy first. The service proxy intercepts the request, checks its internal routing rules, and seamlessly forwards the traffic to the appropriate pod and container running inside it. This is how control plane management and worker node execution work together to create a scalable, resilient, and self-healing environment. And that is the complete, step-by-step breakdown of Kubernetes architecture. Hopefully, following this diagram helped clarify how the control plane and worker node components function together. If you found this video helpful, please give it a like and share it with your fellow DevOps engineers. If you have any questions or want us to cover a specific cloud topic next, leave a comment down below. And don't forget to subscribe to Nexus IT Insights for more DevOps and cloud tutorials. Thank you so much for watching, and I'll see you in the next video.